8.2, apply exponent properties involving quotients.
Grace and Sam are going at it.
It was actually more of Grace.
All right, quotient of powers property. So obviously we had a lot of properties we got yesterday, and same thing. You don't need to know the name of them. You just need to understand how to use them. So let A be a non-zero real number and let M and N be positive integers such that M is greater than N, and that's important to this problem because we would do something totally different if that wasn't the case. So this will be A to the M divided by A to the N because we're doing with quotients. So this is just like if I had 4 over 2, okay, then you would tell me that that's what? 2, right? It divides into it. This is the same thing. This is A to the M divided by A to the N. And this is equal to A to the M minus N. So we subtract the bottom one from the top one. Again, assuming A is not equal to 0, which we've already kind of stated that there, but. So to my example that I just said of 4 over 2, if I adjusted that ever so slightly, we could do 2 cubed over 2 squared, and that would be 2 to the 3 minus 2, which would just be 2, right? Or this is 8 over 4, which is 2. So in words, to divide powers having the same base, subtract the exponents. All right, this next one's interesting. We actually had a problem that we had to look at this yesterday for as well, but now it's officially coming up. That's why I was surprised to see it yesterday. But the power of a quotient, so the other one was a quotient of a power. This one's the power of a quotient. So let A and B be real numbers with B not equal to 0, and let M be a positive integer then we would have something like A over B all raised to the M is equal to this, much like what we did yesterday when we had A times B raised to the M, that M went on both things. If we have a fraction, it goes on both things in there as well. So this is going to be A to the M over B to the M. And this is all assuming B is not equal to 0, because we can't have 0 on the bottom. So if I had something like 4 over 5 raised to the third. This would be 4 to the third over 5 to the third. So it splits and goes on both pieces. So now, some of what we're about to do is going to still involve using the rules that we learned yesterday. So don't forget those. Don't let those disappear into thin air, right? We still need to be able to use them because we could have multiple things on top and something on the bottom, and it would be applied to all the different pieces, okay? So, getting into some examples here. These ones say simplify the expression, write your answer using exponents. So this will be like the first ones we did yesterday, and then we'll jump into some where you'll multiply through if it's something that we can multiply and whatnot. So number 4, I've got 2 raised to the 11th over 2 raised to the 6th. So I subtract this one up here. So this is going to be 2 to the 11 minus 6, which is 2 to the 5th. And that's how you would leave that one. Okay, so in these ones that want your answer written as an exponent or with exponents, we'll do the same thing we did yesterday. You need to show these steps out when you move down into the later ones. You're welcome to show it, but if you want to skip that part, you can. Okay.
It was a tour.
Oh, I was like, if there's a class going in there, I'm going to have to move her somewhere else. All right, number 6 is -6 raised to the 8th over -6 raised to the 5th. So this one, the -6 is in parentheses on both of these. So this is going to be -6 raised to the 8 minus 5, which is -6 cubed. Now, just out of curiosity, that's where this problem stops. But would this final answer be positive or negative?
Negative.
Negative, why?
Because yeah.
It's an odd power, so it'll stay negative. Let's see. That one's like the exact same. Number 10. Did I throw anybody off skipping number 8?
Yes.
Yes.
Wait, what was number 8?
Literally the exact same thing as this, except for it was a 12 instead of a 6.
Oh.
The powers were different, but I was doing the exact same thing, so I skipped it. 6 to the 7th times 6 to the 4th over 6 to the 6th. So, what I would say to do is anytime we have something like this, simplify the top or the bottom first and then simplify the thing as a whole, okay? So I would pretend that this bottom part doesn't exist for right now. What do I do on the top? These are the rules from yesterday.
6 to the power of 7 plus 4.
Yep, so on top I've got 6 to the 7 plus 4 over 6 to the 6th. So that is 6 to the 11th over 6 to the 6th. Now I can do the next step of subtracting 6 to the 11 minus 6, which is 6 to the 5th.
That looks oddly similar to the problem.
Yeah. Number 4. No, just
12,
You right.
3/2 raised to the 4th. So when it's outside like that of the parentheses, it goes on the top and the bottom. So this is 3 to the 4th over 2 to the 4th. And that's all you can do with that because these numbers do not have the same base. Okay, now, obviously if we weren't writing things in terms of exponents, we would multiply that out and get the actual numbers. But this one's leaving it like this. I've got negative 2/5 raised to the 5th. So this 5, the power goes on the 2 and the 5 and the negative sign. So is this going to stay negative or is this going to become positive?
Stay negative.
It's going to stay negative because it's an odd. So it's going to be negative 2 to the 5th over 5 to the 5th. (16) 1 over 9 to the 5th times 9 to the 11th. What do you think I need to do with this one?
Simplify.
Well, that's the instructions.
Okay, well, okay, now how do we distribute? How you can't distribute
No.
that. Well, no, you can.
Let's just simplify.
You could do 9 to the 11 plus 5. And then
How about you do the fraction first?
Instructions of video.
Oh wait, make the
How about I make this one fraction first?
Oh wait, I was thinking that.
Oh.
I was thinking.
Yeah,
no, you
I
were
was
gonna say
thinking.
that. I was gonna say.
I literally
So this would just be 9 to the 11th over 9 to the 5th.
Yeah.
Sammy did
Now
not say
what
that.
would I do?
Subtract.
Subtract.
Now I would subtract and get 9 to the 11 minus 5, which is 9 to the 6th.
Did you get 4?
Four.
Come on. You're talking about basics. Go back to first grade.
Oh, video, what the heck?
My hands slip.
How do you your hands slip?
My hands, like how
Is
you're,
that 50 point
like how
five?
I'm now.
Guys! Can you say it one more time?
How do you simplify the 9 to the 5th and the 9 to the 11th? Is it just become whatever was on the bottom?
No, so I multiplied up here first. I imagined like this was over 1, basically.
Oh, okay.
And then I did 9 to the 11th over 9 to the 5th. So just multiplying the top and the bottom. There just wasn't anything on the bottom.
Okay.
And then we just followed the normal pattern of just subtracting after that. 18. 4 to the 9th times, in parentheses, negative 1 over 4 raised to the 5th. So in this case, a little bit different than the last one, I would work in that parentheses first, and then I would combine my stuff. So what is this out here telling me to do?
Distribute.
Okay, and what do I get when I do that?
Negative 1 to the 5th, and then negative
4 to the 5th.
So is this going to stay negative or is it going to become positive?
Stay
Stay
negative.
negative.
Going to stay negative. So I don't even really need to write 1 to the 5th for the sake of just us seeing it. And if you go back, I'm going to show that, but we don't have to write it that way. And then this is over 4 to the 5th. So then now I can do multiply the top together. It disappeared.
What?
Just
What
like,
just happened?
I guess I accidentally touched it.
Wow.
So now 1 to the 5th is just what? 1. Now it won't go away. There we go. So then on top I've got 4 to the 9th over 4 to the 5th. I don't want to forget that negative sign, so I'm going to put it back out front. And then now I would have negative 4 to the 9 minus 5, which is negative 4 to the 4th.
You're trying to do 4 to the 4th.
Something tells me it's gonna get messy.
All right, now we're going to get into variables. So we've so far been working with just numbers in this section. We're going to jump into some variables, and then they're going to mix some numbers and variables together. So these ones just say to simplify. So at this point, you do not have to show this subtraction step anymore. If you want to, that's fine, but you don't have to. So 22, z to the 8th times 1 over z to the 7th. What would I need to do first with this one?
8 over z.
8 over z.
Z to the 8 over z to
Yeah.
the 7.
Yep. Z to the 8 over z to the 7. And that's going to give me what?
Z to the first.
Yep.
So just
Z. Yep, it's z to the, I'm going to write this out just so we have it. Again, you do not have to. This would give me z to the 1, which I would write as just z. Okay, so you can go straight from here to here.
Oh, yeah.
Once we get to these problems that just say to simplify, the ones that need to be written as exponents, we need to show out that step to make sure that we've got it down. 24. J over K raised to the 11th. What do I do with one like this? Yep. So it's J to the 11 over K to the 11.
What?
Just kidding, guys. Just kidding.
We're talking stuff.
26. In parentheses, negative 1 over x raised to the 5th. So what happens here?
Distribute.
Distribute.
So
And
you
it's
get
still
negative
negative.
1 to the 5th and then x to the 5th.
Yep.
Always negative.
So is it going to stay negative or is it going to
Yes,
switch to
stay
positive?
negative.
It's going to stay negative, and then I would have 1 to the 5th, which I'm not going to write, and then over x to the 5th. And I'm only not writing 1 to the 5th because 1 to the 5th, 1 to any power is just 1. And so that would be all on that one.
Every time we get a negative, it's always 5.
No, I finally don't have my ability.
28, in parentheses, negative a over b raised to the 4th.
Oh,
The same thing we've been doing as algebra 1. But it's positive this time.
Okay.
Amen.
It's raised to an even power, so this one's going to be positive. So just for reference, I'm going to put the positive sign there. You don't have to do that. And then I would have a to the 4th over b to the 4th. So normally I would just write it as a to the 4, b to the 4, like that.
Wait,
Bro.
How did you not know that?
8.
All right.
30.
30. A to the 7th over 2b, all raised to the 5th.
Ooh, this one's different. I think we gotta. Oh, I think I know what we're doing.
This
You
one's
times
easy.
the
Distribute.
7 by 5.
So you times.
Yep. So the top,
Right.
it would be, I'm just going to write this out step by step so we see it. This would be a to the 7 raised to the 5, which would be a to the 35th, because we would multiply that. Now on the bottom, what happens?
2 to the 5th and b to the 5th. You gotta distribute.
2 to the 5th and b to the 5th. It goes on both pieces. So then, what is 2 to the 5th?
32.
32, b to the 5th is what I would be left with. So a to the 35 over 32, b to the 5 would be the answer to that one.
Can't wait to do another one of those 48, 49 problems.
You got it.
So this one will be even harder.
I hated that problem.
49 was actually not that bad.
I
Yes.
had my brother help me with that
Yes,
one.
it was. It was that bad.
It's just the same thing.
32. 3x to the 5th over 7y squared, all raised to the 3rd.
Alright, guys, I get it. I know what we're doing.
All right, so piece by piece, what's happening here?
We gotta
Because
The
tribute.
5 and the
And then
13
times,
get
so 5 and
times.
the 2.
Yep, so this cube goes on every single thing in here. So this would become, again, I'm writing out step by step. You wouldn't have to do it to this level. 3 cubed. Then I would have x to the 5th cubed over 7 cubed. Then y squared cubed. Okay? So what is 3 cubed?
27.
27. What is this? X to the 5th cubed.
340.
X to the 15th. What?
I was doing 7 cubed.
That's not what I asked for. Over 7 cubed is
343.
343. What's y squared cubed?
Y to the
Y
6.
to the 6.
Yep, we multiply, so y to the 6th. That's good. It sounds like we actually understood our homework last night.
I did.
Yeah.
Except for one problem.
Except 49.
I'm like, it was.
49
I
was not
understood
that
everything
bad.
except.
Okay,
Okay, Jonathan, you were the one complaining about it. You're like, 49 is so long and hard.
Honestly, 37 was
You
harder than
sound like
49.
I agree.
Many hours.
49 is all my math problems.
2x cubed.
No.
You times the 3 and the 3.
Distribute.
This isn't the whole problem. I'm just waiting on people to be quiet. 2x cubed over y cubed, and then times 1 over 6x cubed. All right, so working with this part first. What do I do with this cube?
Times it by the
Times it.
problem.
So this is going to be 2 cubed, then x cubed cubed over y cubed times this 1 over 6x cubed. All right, what does this give me over here?
X to the 9th and that's just 8.
Okay, so I have 8 x to the 9th over y cubed times 1 over 6x cubed. Now what?
Multiplying 6.
Cross multiplication.
Cross multiplication is across a equal sign.
The x's. Divide the x's. We gotta subtract the x's.
Okay, first of all, I should combine this into one fraction and get 8x to the 9th over 6x cubed y cubed. Now what?
Then we do the x's.
What else can I also do?
Exponents.
Exponents. Like the 8, that's the x.
That's not an exponent, but
You could multiply them? Or to divide?
what is 8 over 6?
4 over 3. Sorry.
Okay, now on top, I can do x to the 9 minus 3, and the y cubed stays down here. So my final answer then is 4x to the 6th over 3y cubed.
Yes. I got that.
Yeah. Okay, I get that. I get that.
All right, then try this last one on your own.
Alright.
Well, it's not actually the last one, but the last one in this little part. We're doing more after that.
Number 38.
36. Negative 5 over x squared times 2x to the 4th over y cubed, all squared.
I'll do it by myself.
Hey.
Oh yeah, that's right. So,
Yes. Uh-huh. Bye. Ren, you're apparently leaving.
Can I have the homework?
I'll text you tomorrow.
Okay.
I haven't picked out all the moms that were here yet.
I don't know.
How do you know?
Because mine matches yours.
I don't know.
At the meeting.
I'm always right.
Wait, what is your answer?
All right, what do we get?
100x6 over y6.
You got it.
We agree?
Yes.
Wait, say the answer again? I got 100x6 over y6.
That's what I got.
That's what I got. After I'm out.
Beautiful. That's the right answer.
Yes!
That's what you got after you modified it.
No.
All right, so the negative sign becomes positive. And then I have 5 squared over x squared times 2 squared x to the 4th squared. And then over y cubed squared. So then that gives me 25 over x squared times 4x to the 8th over y to the 6th. And then combining that top and bottom, I get 100 x to the 8th over x squared y to the 6th. I subtract the x squared from the x to the 8th. Or, well, not like subtract. We subtract their exponents. And then ultimately get 100x to the 6th over y to the 6th. Any questions on that one?
I'm surprised I got it right.
I just forgot how to do simple multiplication for a second.
At one point,
I
I
forgot
got
it was exponent,
confused.
so I
I got
did
confused when I got to 25 times 4x, and I was like, oh, I can multiply.
Oh, I divided.
Yeah, that's where I had gotten stuck at. I'm like, what do I do?
It's quick. So, like,
Yeah,
every
gotta do
time
math
there's,
first,
like, for this, like, where there is, like, 2 x's and, like, the 1 is up top, do you always, like, subtract it?
For what you know to this point, yes. Right now, we always move from the bottom to the top and we subtract.
I think
I'm not going to try to confuse
top to the
anybody,
bottom.
but there are times that it can move the other direction.
Oh, no. It is.
But for right now, everything's going bottom to top. All right, 42. I bet you can guess.
Oh, no.
2f squared g cubed over 3fg raised to the 4th. All right, so what do I do?
Distribute.
Okay, so this is going on every single thing. So this is going to be 2 to the 4th, f squared raised to the 4th, g cubed raised to the 4th, over, goes on the stuff on the bottom too, 3 to the 4th, f to the 4th, wow, I can't even talk, g to the 4th.
Oh, wait.
So what is 2 to the 4th?
16.
What is f squared to the 4th?
8. It's 8.
F to the 8th. What is g cubed to the 4th?
G to the 12.
G to the 12th. Over 3 to the 4th.
3 to the 4th is 81, right?
81, and then I've got f to the 4th, g to the 4th. Nothing's happening there. Now what do I have to do?
Combine, subtract the terms for f and g. So you can't do much of the next
Yep.
numbers.
16 and the 81, nothing comes out of those. So I'm going to end up with 16 over 81, and then, well, on top, f to the 8 minus 4, and g to the 12 minus 4. So I end up with 16 f to the 4, g to the 8 over 81.
This is easier than last lesson. Like,
Yeah.
Well, it's easier because you've done last lesson.
exactly.
Some books teach this all in one, but I kind of like that this one does it separate.
That too.
It's kind of
I
nice.
remember really why.
Shove it in there, man. Yeah, wait, no.
All
right.
No,
One more. You're going to try on your own and see how we do. And then you will have your problems. 2m to the 5th n over 4m squared. All of that is squared times m times n to the 4th over 5n squared. That is not the right button.
Not okay.
What is happening?
Is it not working?
I don't know what's happening. I'm just gonna. Now it froze. Okay.
The memory
And now it's. What is. I don't understand.
Has this happened before?
Yeah, it happens a lot. I hit the wrong button. Apparently, I hit the video button instead of the camera button. That freezes it. Anyways, y'all keep working.
It's different now.
These are some massive numbers.
Okay.
Sam.
That'd be dope.
I knew it was coming once Jonathan said it. I was like, Sam.
Just the way Sam says looking afraid is just.
There's a couple different ways that you could take this problem and go with it. So as long as you get to the right final answer, it's fine of whatever your in-between steps are. All right, did we get to an answer?
Not yet.
Not yet.
Okay.
I did, but like, that took me like 5. That took me like 20 entire spots. 100.
It's okay. This was a long one. And I tried to do everything like a little like step by step for y'all to like be able to see it.
I just can't tell whenever I'm at the end or what.
This one is so thick. Like, I
When there's
thought about
nothing,
it.
so when all your numbers have been multiplied together, like combined, and you can't reduce anymore, and then when there's each variable's written only one time, that's how you know you're at the end.
Oh, wait, I think
Is
I
there one
know.
of those-
Like you shouldn't have a variable left, like where you have like, say like m times m on the top. You should have that as like m squared, or you shouldn't have like m cubed over m. Like you should be reducing that. So as long as you just have each variable written once, Numbers could have numbers on the top and the bottom. If they reduced, then that's great. But like in the last problem we did, we had 16 over 81 as like the numbers, and that couldn't go any farther. And for the sake of this lesson, well, I'm not going to say we can't have variables on the bottom. Obviously you can, but next lesson we'll have stuff going everywhere. The next lesson is to answer your question. We won't just be moving everything to the top. All right, what did we get? If we're not there yet, that's okay. Somebody that's...
and a over 100.
We agree?
That's what I got.
What?
Yeah! Oh, I did do it! Yeah.
Oh,
That's
No, so
miracle.
close, bro.
All right, so the first thing I did, again, I did everything as step-by-step as possible. There were different intermediate steps that you could have done to get here, okay? So the first thing I did was I distributed this 2 to everything in there, okay? And then I did it over here on this one as well. Then when I multiplied the exponents that were like a power to a power, and that led me to right here. So I had 4 m to the 10th n squared over 16 m to the 4th times m squared n to the 8th over 25 n squared. At this point, what I did is I combined the top stuff and then I combined the bottom. You could have instead reduced here and done m to the 10 minus 4 and gone ahead and reduced this 4 and this 16, or you could have done n to the 8 minus 2. That's just not what I chose to do. I did everything across the top and everything across the bottom to give me 4 m to the 10 plus 2, n to the 2 plus 8, over 16 times 25 m to the 4 n squared. I could have reduced at any point in there with that 4 and that 16. So in this step, well, I left the 4 and the 16 initially, but then I ended up going back and reducing it. So that ended up giving me 4 times 25. I had m to the 12th, n to the 10 over m to the 4 n squared, obviously with this number left over. That stuff ended up being 100, and then I subtracted the stuff from the bottom, so m to the 12 minus 4 and n to the 10 minus 2, which gave me m to the 8, n to the 8 over 100. Any questions on that? Obviously, that was an excessive problem. That was quite long, but that's as hard as they're going to get. So you should be all right. So 3 through 35, every other odd. That's actually not that many problems. Okay, I want to make sure we understand what every other odd means, because if we've done it, it's been a while, I think. It means 3, skip 5, 7, skip 9, 11, skip 13, 15, and so on and so forth. Okay? Does that make sense? Do I need to write them all out, or do we know what we're doing? All right. Fortunately, the way these work is it's pretty much straight down a column. So it's like 3, 7, 11, 15, they're all stacked on top of each other. Then you have to do 19, and then you start 23, 27, 31, 35. They go down like a column, so it's kind of easy to see. And then 43 and 45 are just separate, the harder ones like what we just did. So it is Wednesday, and there's not a ton of time left, so obviously we may have to, at the beginning tomorrow, give a few minutes or just make sure that there's time. But this stuff isn't due till Friday. There's not that many problems. You actually could probably knock out at least the first like 5 or 6 problems before class is over. So